Welcome back to Knowledge Hub. What is the shape of the universe? If you could somehow manage to step outside of the universe, what would it look like? Scientists have struggled with this question, taking several different measurements in order to determine the geometry of the cosmos and whether or not it will come to an end. How do they measure the shape of the universe? And what have they found? The geometry of the cosmos. According to Einstein's theory of general relativity, space itself can be curved by mass. As a result, the density of the universe, how much mass it has spread over its volume, determines its shape, as well as its future. Scientists have calculated the critical density of the universe. The critical density is proportional to the square of the Hubble constant, which is used in measuring the expansion rate of the universe. Comparing the critical density to the actual density can help scientists to understand the cosmos. If the actual density of the universe is less than the critical density, then there is not enough matter to stop the expansion of the universe, and it will expand forever. The resulting shape is curved like the surface of a saddle. This is known as an open universe. If the actual density of the universe is greater than the critical density, then it contains enough mass to eventually stop its expansion. In this case, the universe is closed and finite, though it has no end, and has a spherical shape. Once the universe stops expanding, it will begin to contract. Galaxies will stop receding and start moving closer and closer together. Eventually, the universe will undergo the opposite of the Big Bang, often called the Big Crunch. This is known as a closed universe. However, if the universe contains exactly enough mass to eventually stop the expansion, the actual density of the universe will equal the critical density. The expansion rate will slow down gradually, over an infinite amount of time. In such a case, the universe is considered flat and infinite in size. Measurements indicate that the universe is flat, suggesting that it is also infinite in size. The speed of light limits us to viewing the volume of the universe visible since the Big Bang. Because the universe is approximately 13.8 billion years old, scientists can only see 13.8 billion light-years from Earth. Measuring the cosmos. Scientists studying cosmology measure the expansion of the universe and its density to determine its shape. While studying distant galaxies in the early 20th century, astronomer Edwin Hubble realized that they all seemed to be rushing away from the Milky Way. He announced that the universe was expanding in all directions. Since then, astronomers have relied on measurements of supernova and other objects to refine calculations of how quickly the universe is expanding. Other instruments measure the background radiation of the universe in an effort to determine its shape. NASA's Wilkinson Microwave Anisotropy Probe, WMAP, measured background fluctuations in an effort to determine whether the universe is open or closed. In 2013, scientists announced that the universe was known to be flat with only a 0.4% margin of error. Thanks for watching.